we're going to learn how to rationalize a SURD. So if you look at the two examples we have on the screen, right, look at the first one, 20 over square root 2. Observe that the denominator is a SURD, right? So rationalizing a SURD means we're going to make the denominator a non-SURD. So recall that we have learned earlier on that square root a times square root a will gives you a, right? So if you, example, if you have square root 2 times square root 2, and that will gives you a 2, right? So what we're going to do is we're going to multiply this with square root 2 over square root 2. So you would have 20 times square root 2, that gives you 20 square root 2, and then your denominator square root 2 times square root 2 will gives you 2. And from there we can further simplify it as 20 over 2 times square root 2 over 1. So 20 divided by 2 is 10. Square root 2 divided by 1 is square root 2. So that gives us 10 square root 2. Okay? So this is what it means by rationalizing the SURDs. Alright, so rationalizing the SURDs means to make the denominator a non-SURD. Okay? Right, so let's look at the second example. So how do I rationalize it? I just multiply with the square root 18 over square root 18. So I would get 30 times square root 18 over 18. Now we have also learned earlier on how to simplify SURDs. Right, so square root 18, we can actually rewrite it as, right, square root 9 times 2. Right, remember the 9 is a perfect square. Right, because square root of a perfect square will give us an integer. Right, so what we'll be having here is 30 times square root 9 times square root 2 over 18. Right, so we will have 30 times, so square root 9 is 3. And we can further simplify it. Right, you can just use a calculator to help you. This one here, if you use a calculator to help you, that will be fractions 30 times 3 over 18, and that gives you 5. So that will be 5 times square root 2 gives you 5 square root 2. Get the three terms that you're given on the screen. Which is the one that you need to rationalize it? Yes, the third one, because the denominator given here is a SURD. Right, so we need to rationalize the third term to make the denominator a non-SURD. Having said so, we can also simplify the first two terms. Right, so we can rewrite 112 as a perfect square, multiplications of a perfect square and another number. So we can list down the factors. 112 divided by 2, that gives you 56. So none of them is a perfect square. So 112 divided by 3, no. 112 divided by 4, no. 112 divided by 6, no. 112 divided by 7, yes. So we can try, and then finally we have 7 times 16. So 16 is a perfect square. Right, so 112 we can write it as 7 times 16. So for 28 it's rather easy. It will be 4 times 7. Okay, and for the third term we need to rationalize it. So how do I rationalize it? I just multiply it with the square root 63 over square root 63. Okay, so here we can apply your square root 7 times square root 16. Recall this rule that we have learned earlier on. Right, square root AB give you square root A times square root B. So we're just simply applying the rules we have learned earlier. Right. Okay, so here I will have square root 7 times 4 because square root 16 is 4. Square root 4 is 2, so 2 times square root 7. And 63 we can break it down into 7 times 9. All right, let's simplify further. Okay, so these two we can combine them. That will give us square root 7 and then 4 minus 2. The common factor is square root 7. And here I can apply the rules again, which give us square root 7 times square root 9. Right, so let's continue. So this term here that will give us 4 minus 2 is 2. So square root 7 times 2 will give you 2 square root 7. And let's continue to simplify the second term. Square root 9 is 3. All right, and then we can group all this number together. 231 times 3 times square root 7, then over 63. Right, so this 231 times 3 over 63, you can easily use the calculator to help you evaluate the answer. So that will give you 11. So you will have 2 square root 7 plus 11 times square root 7. And then that will give you square root 7 is a common term. You can extract it out. So that will give you 2 plus 11. And that gives you 2 plus 11 will be 13. So that will give you 13 square root 7. Right, so what happens if you're given a questions where the denominators is a combinations of a real number and a surd? It's not just a surd alone, but it is a combinations. Right, so if you're just going to multiply with the square root 7 at the numerator, also at denominator, let's see what happens. Huh? Right, can you see that we did not actually manage to rationalize the denominator into a non-surd? Can you see what we are getting? There's still a surd there, square root 7, right? So in this case here, we can't actually just multiply it with square root 7 at the numerator, also at denominator. So we need to learn something called the conjugate surds. So what is conjugate surds? Right. So 1 minus square root 7. The conjugate surd is 1 plus square root 7. Right, if you will recall earlier on, I think the simplifications of surds, we learned that if you have a 2 minus square root 3, and if you multiply with the 2 plus square root 3, right, that will give us bracket 2 squared minus bracket square root 3 squared. That will give us 2 squared is 4, and square root 3 times square root 3 is 3. That will give us 1, which is an integer. Right, so 2 plus square root 3 is the conjugate surds of 2 minus square root 3. So 2 minus square root 3 and 2 plus square root 3 are called conjugate surds. Conjugate surds. Okay, so if I were to use instead of a number as a variable, so if you have, let's say, a plus b square root 3, then the conjugate surds will be a minus b square root 3. So you see that the terms remain the same. The only difference is the operation in the middle. Okay, one is plus, the conjugate surds is negative. Right, let's have another example. Let's say if I have a square root b minus hk, then what will be the conjugate surds? So the conjugate surds will be square root b, but instead of minus, it's plus that hk. Back to the previous example, right? So the conjugate surds for 1 minus 7 will be 1 plus square root 7. Right, so I'm just going to multiply with 1 plus square root 7 at the numerator, 1 plus square root 7 at the denominator. And let's see what happened. Okay, so that will give us 1 squared minus bracket square root 7 close bracket squared. Okay, right, so that will give us 3 plus 3 square root 7 over 1 minus square root 7 times square root 7 is 7. So 3 plus 3 square root 7 over negative 6. Right, we can factorize 3 out. So 3 divided by negative 6 will give us negative half. So you can present your answer as negative half bracket 1 plus square root 7. Or you can leave your answer as negative 1 plus square root 7 then over 2. Let's do a more difficult questions. So first of all, let's look at the denominator, and let's write down the conjugate surds for the denominator. So the conjugate surds will be 3, then plus, all right, because what you're given is a negative there, so conjugate surds will be 3, then plus 2 square root 7. Right, so we're going to multiply with 3 plus 2 square root 7 over 3 plus 2 square root 7. Right, so this is what you will get. Right, so the denominator, right, you will have bracket 3 squared, then minus, okay, remember it's a minus here, then bracket 2 square root 7 close bracket squared. Now actually, this part here, you can use your calculator and you will get an integer, right? If we don't want to use a calculator, we can still work it out. So 3 squared will be 9, and then 2 square root 7 times another 2 square root 7. That will give you 2 times 2, then times square root 7, then times another square root 7. Gives you 4 times 7, 28. Otherwise, you can just use your calculator to help you evaluate. You should get negative 29 minus 28. You will get negative 19. If you use a calculator correctly, if you punch in the number correctly, you will get negative 19 for the denominator. So for the numerator, what should we do? We will use the distributive law. Right, so we will have 3 square root 7, then plus 2 times square root 7 times another square root 7, minus 3 times 3, that gives us 9. And positive times negative is a negative, so there will be 3 times 2, then times square root 7, and over negative 19. Alright, so we would have 3 square root 7. So here, right, square root 7 times square root 7 is a 7. So 7 times 2 will give us 14. And this will give us 6 square root 7. Alright, we can further simplify it as in like 14 minus 9 will give us 5. And then we can put our surds together. That is 3 square root 7 minus 6 square root 7 over negative 19. And here we can factorize your square root 7. That gives us 3 minus 6 over negative 19. So that will give us 5. 3 minus 6 is negative 3. So 5 minus 3 square root 7 over negative 19. Okay, there's no more common factor. So the final answer, we can just put the negative in the middle instead of at the denominator. Then 5 minus 3 square root 7 over 19. So this is how you rationalize a surd with rationalize the denominators of a surds with its conjugate surds.